Hi students. Previously we talked about how can we separate a solid liquid mixture and the 4 different methods. So now let's go through the 4 different methods one at a time. So in the event that I want to obtain insoluble solids from a solution or liquid, example your sand and water or your chalk and water, I will use filtration. So in a filtration setup, there are 2 important terms that you need to know. What is a residue? What is a residue? And what is a filtrate? So residue is the solid that remains behind in the filter paper after a mixture is poured through a filter paper, because this residue is insoluble in the liquid. So when they are insoluble, they remain as large insoluble solid particles that get trapped by the pores of the filter paper in the filter funnel. So you notice that this little blue line here, these are actually the pores of the filter paper. So since the pores of the filter paper is too small for the solid to pass through, the solid will remain behind. But for the liquid particle, it will pass through because they are small enough to pass through. Alright, so for the filtrate, it's the liquid that pass through the filter paper. So I hope that everyone will be a filtrate in the upcoming WA1 and no one will be left behind as a residue for this WA1. Thank you. Let's move on to the next one. So for the next one, let's look at evaporation to dryness. It's a method to obtain a soluble solid from a solution by heating the solutions until all the water has vaporized. So in simple words, we just want to remove the liquid from the solution. How? I'll just evaporate the liquid away. Simple as that. So there are some limitations like I mentioned in the previous video. So sometimes the solid obtained might not always be pure. Why? There might be some soluble impurities that are left behind after all the liquids are evaporated away. So it's not really a pure solids. So what can be done? We will use crystallization. Moving on to the next one. So crystallization, if you look back at the flow chart, is a method to obtain a pure solid which is soluble from its saturated solution. So some examples will be your hydrated copper 2 sulfate crystal, your sodium carbonate crystal. So there are actually 5 steps for crystallization. First one, I need to saturate, meaning I will heat the solution until most of the liquids are evaporated to obtain a saturated solution. After that, I'll just leave the hot saturated solution to cool down at room temperature. So the second step will be to cool down. Why do I need to cool down? Because I want the crystal to be formed. Next, after the crystal are formed, I want to obtain the crystal. I don't use my hand to take it out because some crystals are very small and I don't want to contaminate the crystal as well. So what do? I filter. After I filter, I will wash and dry the crystal. I'll wash the crystal with a little bit of cold water and dry them between sheets of filter paper. So wash and dry. So now the question is, how come I cannot use hot water to wash the crystal? So let's look back again. So at the start, I have a solution and I want to obtain a solid from a solution. So I go through so much effort to saturate, to cool down, to form crystal, and I filter. If I pour hot water back into the crystal will dissolve in hot water, and eventually what happens? I'll get back my original solution. So all my effort are wasted in trying to obtain the pure solid. Because hot water will dissolve all the crystal. Because some solids are very soluble under high temperature of liquids. So the solid that are obtained using crystallization are typically soluble in water. So if you pour hot water, they will just dissolve back. And this solid will be less soluble at lower temperature. So that's why once we cool it down, you notice that these solids are not so soluble and they will appear as crystal. And that's why we need to wash this crystal with cold distilled water to allow more crystal to be collected. Because if you wash with hot water, all our crystal will be gone. Why? Because they will be dissolved. Okay, bring on to the last one. Okay, so I believe I have shown you this video class on how does simple distillation works. So the purpose of simple distillation is the opposite of evaporation to dryness and crystallization. Why? Because instead of obtaining the solid, I want to obtain the liquid. So I obtain the liquid from its solution. Example will be to obtain water from seawater. So what will happen? At first, all my mixture will be heated up. So it will heat up. So once the solvent in the mixture is heated up, it will become my vapor. So this vapor will travel upwards and into the condenser. Why? Because there's a stopper over here. The stopper prevents the vapor from escaping out of the flask. So once the temperature reaches 100 degrees Celsius, that means this is the boiling point of water. So the water vapor will be going downwards into the condenser, and the condenser helps to cool down the vapor to condense back to liquid, and eventually the pure liquid will be condensed and collected as a distillate in this conical flask. One thing to take note is, where does the water go in to the condenser and where does it go out of the condenser? This is very important. And I have shown you in class what happens if I do the other way around. So if you're still not too sure, you can look back at the video again. Alright. So now let's understand some setup and process. Why are we doing this? Why are certain apparatus placed in this manner and stuff? So suggest why the bulb of the thermometer must be positioned at the outlets connected to the condenser. Because you want to measure the temperature of the vapor that's moving into the condenser. Next, explain why water enters the condenser closer to the conical flask and exit the condenser closer to the distillation flask. Because the water enters the lower end of the condenser to ensure that the ends remain cool throughout the process, and if there's any remaining vapor near the lower end of the condenser, it will still condense to a liquid. This will ensure that most of the solvent is still collected back as the liquid distillate. Lastly, why do we use boiling chips in the flask? To ensure smooth boiling. And lastly, as simple distillation proceeds, what do you think would be present in the distillation flask? A saturated solution containing the solute and a smaller volume of the solvent. Because as you heat up, as time goes by, there will be lesser and lesser solvent inside this mixture, and there will be more and more of the soluble solids left behind. Okay, so we have gone through filtration, evaporation to dryness, crystallization, and lastly simple distillation. So we'll stop here for this video. Thank you.